In this video, we're going to look at measuring volume. Here's our first question. The figure below to the right is the front view of a three-dimensional object made up of stacked cubes. How many cubes make up the volume of this figure, including the ones we cannot see? Okay, so notice this would be the front of the cubes, and there would actually be cubes behind and underneath these cubes that are holding them up. Okay, so we can count the ones we see. There's 1, 2, 3, 4, 5, 6, but there's also cubes behind and underneath. So let's first draw what the bottom may look like if we lifted up these cubes, the top two rows of cubes. So we would have, this is cube, let's label this 1, 2, and 3. Okay, and this would be cube 1, cube 2, and cube 3. Okay, now underneath these two cubes, there would also be cubes. Let's do those in a different color. These will be the ones we can't see. Okay, excuse my bad art skills. Okay, but underneath this cube would be cube 4, and underneath this cube would be cube 5. And then this cube, okay, there'd be 2 rows underneath it. So all the way in the back, we'd have 1 cube on the bottom row underneath this cube. Okay, so this is our first row. Now if we look at our second row overlaps these pieces. So let's draw another picture. And it would look something like this. Okay. Now we'll label. We're going to call this cube, we've already gone up to 6, so let's call this 7 and this 8. This is cube 7, this is cube 8, and cube 9 is the cube immediately under this cube. So this is our second row. And then our third row is just this top row, which only has 1 cube. So that is cube 10. Okay, and if you need some help visualizing this, you may want to use sugar cubes if you have them lying around, or some sort of children's toy that you can stack up. So the total number of cubes, well, the first row we have 6. In the second row we have 3. And in the top we have 1. And that's the same as the number we had counted, which is a total of 10 cubes. Let's look at the next problem. Determine the volume of the toy staircase shown by imagining that is filled with centimeter cubes. Okay, so again, you have to see the dimension here. Okay, so if you're looking at the stairs in front of you, this would be the width of the stairs. This would be the top of the first step where you would step. Okay, that's the height of the stair. You step up onto this bottom of the stair, and you continue up. Okay, so notice we're given in this diagram that this is 1 centimeter by 1 centimeter, and we can also see over here how many layers there are to this toy staircase. Okay, so let's think about just one row. Okay, so this 1 by 1 by 10. So we could cut this into 10 pieces. 3, 4, 5, 6, 7, 8, 9. Okay, and imagine these are the same width, and it should be equal to this length. Okay, and if we thought of these as centimeters cubed, or cubic centimeters as our unit of measure, notice there would be 10 of them. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 cubic centimeters in this one stair. Now notice the second stair would be identical. Okay, so this was our first one. The second stair would be identical, so this also has 10 cubic centimeters, but notice it has a row below it that we can't see that's identical to this one too. So now we have 3 copies of the 10 cubic centimeters. And now going to the third step, this is identical to this first stair that we counted, and underneath that one we have 2 more copies of these 10 centimeters cubed. So we have 6 copies of 10 centimeters cubed, which is 60 cubic centimeters. Okay, so our strategy was to count one that we can see and then make sure that we wrote down all of the copies that we can't see that are out of our view, because this is a 2-dimensional image of a 3-dimensional object, so we have to be able to think outside the box, so to speak. Okay, count the number of copies and then multiply to find our results. Now we have one last question. What units would be appropriate to use to measure the following? Okay, and we're asked for U.S. customary units and metric units. So in general, the way you want to approach these problems is think, what unit would I measure each of the dimensions with? Or what unit would I measure each of the dimensions? So if you think about the amount of water in a bathtub, okay, the amount of water the bathtub holds is volume. Okay, so your first thought may be gallons of water, but we're going to use for US either cubic inches, cubic feet, cubic yards, or cubic miles. For metric, we're going to use cubic millimeters, which would be very small, cubic centimeters, which were about the size of cubic inches, a little bit smaller, cubic meters, so meters are about the size of yards, and cubic kilometers. Okay. So when you're thinking of measuring these things, in the U.S. system, inches are the smallest unit that we'll use. Okay, there are things smaller, or partial inches, but we're going to stick with cubic inches. Then feet cubed, yards cubed, miles cubed. In the metric system, there's millimeters cubed, which are very small. Okay, maybe ant size small. Then cubic centimeters. Centimeters are smaller than inches, but they're pretty much around the same length. Okay. And cubic meters, which a meter is about the size of a yard, and a kilometer is about 0.6 of a mile. Okay, so all of these correspond. So if you could think of how you would measure one dimension of the object, then you could use the associated cubic measurement. So the amount of water in a bathtub, for U.S. customary units, I would probably use inches cubed or feet cubed. So let's write feet cubed. Okay, and the reason is when you measure a bathtub, you probably wouldn't want to measure it in inches. Feet would probably be more appropriate because the depth would probably be at least 1 foot. Okay, and the length of the bathtub would be maybe 3 or 4 feet. Okay, the corresponding measurement in the metric system is, I would say, meters cubed. Centimeters are too small. So again, think back to the video that talked about how long each of these individual quantities are, and that's also listed in your packet. The amount of coffee in a mug. So if you were going to measure a coffee mug, just think about one dimension, maybe the height. Would you measure it in inches, feet, yards, or miles? And I would say inches. It's probably less than a foot. So for the amount of coffee, I would measure that as inches cubed. Okay. For the metric, we'd have to choose between millimeters cubed and centimeters cubed. Okay, so there's 10 millimeters in a centimeter. So I think centimeters would be more appropriate because they're a little bit smaller or about half the size approximately of an inch, so I think that would be a better measurement. Millimeters are really for things that are very small. Okay. The amount of helium in a balloon. Okay. Here, if I was measuring a balloon, and granted a balloon doesn't have sides, but you could think of how tall is a balloon, about what's the diameter of the balloon, I would go with cubic inches. I think feet would be too big. So we'll use cubic inches. Okay. And since balloons aren't really tiny, I wouldn't use millimeters cubed. Again, I'd use centimeters cubed. And finally, the amount of fluid in a single tear of joy. So a single tear is very small. Okay. In our U.S. units of measurement, inches cubed is the smallest that we're using. Okay. But when we go to metric, this would be a good opportunity to use cubic millimeters. Okay. And again, to get a good feel of these, you really have to have your own reference point, your own way of thinking about how you measure these units. So I'd say a good example or a good idea is to Google some of these and find some benchmarks for yourself. So you might find out exactly how much fluid is in a single tear of joy. You know what a single tear looks like, okay? And then you can start to make sense of these different measurements.